G'day. Something a little bit different today. A few videos ago I mentioned my maternal grandfather and uncle who were their work in their shed inspired me a bit to take up metalwork and do all those sorts of things. I saw all sorts of things going through their shed. It's faded into the mist of time a little bit, but there were things like car parts for vintage cars, lots of boat parts because my uncle's building a boat, and things like that, as well as bits and pieces for fixing household bits and pieces and so on. So great stuff. Now, as I said, he inspired me, and today he gets to inspire the rest of you. I went out and visited him the other day, and he offered me his drill sharpening machine. Now, as far as I'm aware, this is a unique design. I certainly haven't seen this around the place in the model engineering books or forums and things like that. He was a draftsman for many years, designing tools and things like that, and so I've actually got a full set of drawings for this. Not that I need them, but I've got them, so today I thought I'd show you some of the features of this drill sharpener, and if there's sufficient interest, then we might make a few pieces up and show you how you can build your own if it's not apparent from the show and tell. The grind that this puts on a drill is basically a 4-facet sharpen. It's not quite, because it's actually hollow grinding the drill bit, but when I did the maths I worked out that it was all of something like 0.1 of a millimetre hollow, so it's pretty much the same thing, and the important thing is it cuts. A couple of nice things about it. One is that it's small and lightweight, so it's ideal for a small shop. It's also reasonably quiet, so you don't have to worry about necessarily wearing earmuffs and things like that for hearing. I just think it's a very nice little bit of design, and so I'll run you through it, and we'll see what comes of it. The first thing that struck me about this design was what he's used for the grinding wheel power source. Originally, apparently, he was going to be using an angle grinder, but the shafts of those things are cylindrical, they're difficult to hold, they're noisy. A chainsaw sharpening motor, and if I turn that on, I can still speak over the top of that without any dramas. That's not terribly loud at all. It does the job. According to this, it's got it's about 15% duty cycle, but that's okay because for a drill sharpener you're not using it all the time. What he's got is just that hinges up like so. There's a U-shaped bracket that works on that, and so that just rises and lowers, and when you're sharpening you're lifting in the handle and taking it up and down the drill. On the rear of the unit here are these two claws, and they're just a stop, so that you can hinge that back and the wheel can stay upright. You can adjust things here if you don't want to turn that off, and then come down again. Nice little touch. Notice too, being a fitter, toolmaker sort of person, there's dots here to line things up, and it's a good habit to get into if you're making things like this. That way you know that this part goes at this end and is this side rather than that side. It helps. When sharpening, you're just lifting the grinding head up and down with the handle. It's light enough you don't need to have any counterbalances or anything like that, although I guess you could incorporate one if you wanted to. And the drill sits in the cradle here and goes up and down. There's a locking handle here, which is just a straight clamp on this plate, and there's a knob here for adjusting this in and out. So if you've got a drill set up and you want to just bring it in a little bit more, you can use that to adjust the head back and forwards. This is the mechanism for adjusting the tip angle. Typically a commercially ground drill has got a 118 degree included angle there. For harder materials and thinner materials you can get up to about 135 relatively easily. Anything else you get to grind yourself. Now that tip angle doesn't matter quite so much as people might think, simply because that's been developed over decades, centuries worth of machining empirical studies as to being the optimal one for chip removal and metal removal rates and all that sort of thing, a bit like cutting speeds. So, provided that you're comfortable with the angle, you can have any angle you like. Measuring this one, which has just come off here, that seems to be about 125 degrees. Looks like it'll work, so that's okay. There isn't a scale on here. I guess you could put a scale on if you want. And these are just a hex bolt on the other side here so that you can take that off and adjust it up. This is the mechanism for the primary and secondary angles. There's a locking handle there. And when that's in that position there, this is free to rotate. Now, these are actually a pair of, what would you call them, stops that can adjust around this bolt, and it's clamped with this one here, so that if you wanted to have more primary clearance, more secondary clearance, you could open those out. If you wanted to have less, you could close them in. I'm going to leave them as they are because they seem to work, but there is that adjustability there. Doing the primary and the secondary angle, as you can see, is very simple. It's just a matter of positioning there, locking, you're in your primary position, there, locking, you're in your secondary position. Very simple. The slide here is very straightforward. That piece there has got a T-nut in it, which that handle tightens up on. There's no dovetails or anything like that. This is just a straight strip here, and so if that was loosened right off, this whole thing would come apart. But these are just a couple of guide strips held on with some socket cap screws, running up and down. Nothing terribly complex about that. In fact, it'd be very easy to make, I think, with minimal tools. This lever here is a clamping lever, so that when that's forward, this carriage is locked. When that's pushed back, this adjustment screw can move the carriage. Probably the last major part to look at is this. This is the bit for holding the drill, and there's several bits and pieces involved here. First of all, there's a little adjustable stop here, and there's a straight, well, for want of a better term, a straight knurled knob with a spring on it. So you've got a detent arrangement there, going digital in an analog world. This part here is just a clamp to hold the drill bit in there once you've got it all lined up, and this whole bracket can slide back and forth to cope with different length drills. The machine itself is designed for drills up to about half-inch diameter, but if you wanted to, I dare say you could make it a little bit bigger if you had bigger drills. Either extend this, work out a way of holding tapers, and so on. To get everything lined up, there's this little tooth here, and that just swings down over the top, lines up with the flute, and then you clamp it. Now, that's spring loaded. You can swing that back if you like. Because the arc of the wheel goes up and down here, you could actually leave this sitting there in place and you're not going to damage it. It's only if you start getting into doing flat-ended bits where you might have to move that out of the way. So that basically is the grinder and its features. As you can see, very simple. Wouldn't require a great deal of complexity to make. You probably want a lathe for a lot of these parts, but these things here, if you didn't have a mill, you could probably file them out and do all sorts of bits and pieces. So I guess the next thing is to show you how it works. Now, this drill bit I've sharpened a couple of times. This was conventionally sharpened, but as you can see, it's got a very nice 4 facet on there. Once when you do the first grind of a conventionally sharpened bit to a 4 facet, you'll find that you're grinding a lot off on the secondary clearance here. So I actually had to grind this one twice just to get a nice clean up of the edges, but I'll put that in and show you how it works. As an added accessory, I was also given a container full of these things. Now, these are a little mandrel for sharpening drills. This one goes down to 1/16, I think. A bit like 5C collets, I suspect that you need an individual one for each size. So that's looks like about a 1/8. But they will sit in here like so, and enable you to sharpen smaller drills. So, you know, from about 1/8 upwards, you just use this setup, and this will go up to 1/2 inch, as I said. Once you get down to between 1/8 and 1/16, or you know, 3 millimeters to 1.5, you can make up some little collets to help you sharpen those. And I must admit that sharpening small drill bits is one of those really painful things, because it doesn't take much to get it wrong. So I haven't tried it with small bits, but I've got no doubt it'll do it. And if that's the case, it's a great little sharpener. So I've got my drill bit clamped in here. I've put the tooth down, and it's just sitting on the corner of that tip. I've come down, and with the carriage lock off, I've just come in, so I'm getting you can just hear that, just getting a bit of a scrape. Okay, put the carriage lock on. This is the primary facet. Start that up. I'll now turn it over, locate with the tooth again, lock down. I'll do the primary facet first. And there you go, a four-faceted drill sharpened with the Gower drill sharpener. I think it's a very nice bit of work. I'll probably take it apart and slap a coat of paint on it and all that sort of thing. I've got my Derrick, so I don't know how much use it's going to get, but it's a great little bit of kit. I like it very much. If people are interested in seeing a bit more of the constructional detail, please comment and we'll see what we can do. But in the meantime, thanks for watching, and thank you to my uncle for his inspiration, but also for his drill grinder, because yeah, it's a really nice little bit of kit. Thanks for watching.